So for problem 3, chapter 3, I chose to do percent yield and limiting reactant. Basically for any percent yield problem, if they don't give you the limiting reactant, you're going to need to find it for the problem. So we'll be doing limiting reactant as we solve for the percent yield. So the question I have here is find the percent yield for PbCl2 and the following equation if 30 grams of each one are consumed and 21 grams of PbCl2 are actually made. So the equation we have here is unbalanced. So the first thing we're going to have to do is balance the equation in order to get a correct answer. So we have equal amounts of this on both sides, 3. So we're going to need 2 hydrogens here and 2 Cl's to match these and 2 hydrogens and everything else 6 balanced. So there's going to be a 2 in front of the HCl and a 2 in front of the HNO3. So now that we have that balanced, we're going to need to find the moles for this one and the moles for this one in order to see which one's the limiting reactant. So in order to do that, we're going to need the molar mass. So right now we have 30 grams of this, and we're going to divide it by the molar mass, which plus 28 plus 6. Alright, so you have 331.2 grams per mole, and that comes out to be about 0.09057 moles of our first one here. So this is how many moles can be produced from 30 grams of this substance. The next one we have is HCl. So we still have 30 grams. As the problem tells us, we have 30 grams of each. And then for HCl, a little easier, because only 5.5, and then plus 1. So we're going to get muddy, so it's 36.5 grams, which comes out to be 0.84, etc. So obviously we have excess of HCl, but we don't have a lot of the PbNO3 So this is going to be our limiting reactant here because it does not produce nearly as much moles as the second one. So now that we know the limiting reactant, we're going to use that to find what our theoretical yield is for percent yield. So, now that we know this is limiting reactant, so percent yield is actual over theoretical times 100. So we already have the actual yield actually made. So we already know that this is 21 grams. So we just need the theoretical yield now. Now theoretical yield, we just take our limiting reactant, which we have here. So that's 0.090579 moles. And we have to transform it into the moles for this, which is what we need. So we know that we have, because there's no number here, we have one of these to every one of our product. So every one of these reactants, one of these, so just 1 mole this, over 1 mole this. This is really important because while these are only 1-to-1, sometimes 2 of these could be made, and that means that we would need 1 to every 2 of these, which will change the answer, but it's just 1 to 1. Alright, so then we know that this amount doesn't really change because the ratio is just 1. So now we just need to take the moles and turn them into grams because we have grams for our actual yield, so we're going to need grams for our theoretical yield. You can also do theoretical yield in moles as long as your actual yield is also in moles. Alright, so to get moles, we're going to have 1 mole of this, need the molar mass, and the molar mass for this is 308.2. So that gives us a theoretical yield of 27.916 grams. So now we have to go back to our original percent yield problem, which is written kind of on the side here. Alright, so percent yield. Now we have everything we need for the equation. We have the actual yield, which we get from our problem, over the theoretical yield, which we just figured out, which is 27.916 grams. So all we have to do is divide these, and we find out that our percent yield is about 75%.